aka Matt Podwysocki, aka Lambda Calrissian, coming back to you with yet another set in our series of the reactive extensions Advent of Code, where we'll be going through and explaining little bits and pieces of RxJS so that you, as a developer, can understand where RxJS fits in the grand scheme of things and how you can be productive pretty easily. So let's go over what we've been through so far. So we started off once again creating our observables. So if you haven't taken a look at the Advent of Calendar, just look under my GitHub repo, Matt Podwysocki, and then the RxJS-Advent-2018, and follow along there. So we have the basic idea of what an observable and observer is, in that we had our observer, our observable, and our subscription, so that we could start to visualize our data. So we started then talking about schedulers. It's a fairly interesting but minor part of what makes RxJS interesting, or even .NET or any other variants thereof. We have easy ways of creating observables, obviously through through the easy way with our conversions, or from our creation operators, whether it's generate, range, timer, of what have you. We pretty much have a way of going in and taking a look at an existing data structure and converting it to an observable. So going over here, then we talked about interval and timer and why that's interesting in particular, because if you wanted to do long polling operations, interval is certainly a nice thing to have. And if you want timed operations, to say, I want something to happen 5 seconds from now or 500 milliseconds from now, I can do that. Then we went to converting your data structures to observables via the from operator. That allows you to convert arrays, promises, any iterables, and that includes generators, maps, sets, and so forth, as well as existing observables. So, like I said, you can give it some arbitrary one of those things, or go through of and create anything from an observable. Chances are we've got some sort of integration there with you. So that's kind of nice to have. Then we went into capturing events, and we do that through two mechanisms. Like I've said, is we have the from event, which allows us to pass in basically the event emitter, whatever it happens to be, whether it's the DOM or it's Node.js, or the event emitter in Node.js, or if it's jQuery. For legacy concerns, just as well as we have a custom implementation, so that you, if your particular implementation of events doesn't necessarily fit into one of those buckets with add event listener, or remove event listener, or add listener, or remove listener, or on or off, then chances are we can bind some way, somehow, to that. So we started that with creation, and then I wanted to move more towards composition. So with composition, we had a mechanism called pipe, and pipe was a way for us to be able to compose together operations without necessarily jamming everything onto the observable prototype, and therefore just dealing with this global prototype that everyone's mucking with by adding their own custom operators. Instead, it allows us to import only what we want and tree shake the rest, so that if we only want map and filter, then we only get map and filter. We don't get 299,000 operators that exist in the RxJS world. I know I'm exaggerating just a little bit, but in the grand scheme of things, it's a pretty high number. And if you want to take a look at that operators list, I'm not joking when I say we have a large number of operators, and each one of them, like I said, is very unique and in its own way. Although a lot of them could be, easily just implemented using other operators, and we could deal with a much smaller surface area. But it's the trade-off between developer productivity and discoverability of, so that not everyone has to understand that that merge map or flat map is equal to map and then merge, or concat map is map then concat. Those kinds of things are taken care of for you. We'll talk more about how we merge together sequences a little bit more. And in fact, today we're going to be talking about combining sequences. So the next piece that we covered after the basic piping is implementing mapping and filtering. The idea of taking and projecting a value to from an existing observable to a new observable in the index in which it was yielded in the first place. So really kind of a nice thing to have. And in fact, when creating RxJS, it was one of the goals to make it as compatible with array extras as humanly possible, in that if you knew how to program in functional programming style with arrays, then you would know pretty much that observables have the same programming pattern, except for the fact that instead of for each, calling for each on that, which is a pull-based mechanism, we have subscribe, which is a push-based mechanism. But of course, since we're an incremental collection, unlike arrays, and over time, then we wanted to introduce things like reduce and scan. So reduce takes obviously a finite sequence, but scan is more interesting from the standpoint that you can build up state machines over time by reducing over your given item, whatever it happens to be, and emitting an incremental value. So really cool, really nice thing to have, especially when we started to talk about state machines and state machines over time. We also then covered starting data, prepending or appending data onto the beginning or the end of observables, and then handling any of the defaults if your sequence is empty. So for example, cache data or whatever. Then earlier we covered subjects, and we're going to kind of try to bring this all together in what we did yesterday, which was implementing Redux with RxJS. So going through here again, I finally got the text up for anyone who wants to follow along at home. But we have the way that you can see what Redux is and why it's useful. In our particular thing, we were implementing our standard counter, which is pretty much what everybody likes to do there, which is we create store from Redux. We create an action type, which is either increment or decrement, and our Redux action, which has a type. And then we have our Redux state, which is what we're going to track over time. And then we deal with our reducer here with our state and with a Redux action. So that Redux action being increment or decrement, we can create a new object here that has a new value, +1 for increment and -1 for decrement. Then we can create the store, and then we can render it via the subscribe method. Once again, trying to get you to understand that if you understand programming with observables, you also understand Redux in that way. So then once again, you can go through and you can dispatch these particular actions, whether it's increment or decrement, and in there it will go to our reducer with that action type, and then it will also render the change in our render method. So implementing that with RxJS is actually fairly simple. Not necessarily easy, but I just wanted to throw it out there, is that we can replace a few things in Redux and implement it using the tools that we already have in Rx. So instead of this create store, we have a subject, and then we have a scan and start with. So scan is that, once again, that incremental reduction operator. And start with tells us that we have some sort of initial state that we can deal with. So we can say subscribe, and that becomes, we can pass our render onto that. So once again, really kind of cool in the fact that the logic, for the most part, didn't really have to change at all, other than just some of the naming, and we still get some of the same benefits. Am I going to say that you need to rip out Redux and start all over from Rx? No, absolutely not. I want everyone to continue to use the tools that work for them, and that they find joy and pleasure in. So I'm not necessarily saying, oh, just throw out anything that you've been doing and use Rx, but use Rx where it makes sense. In this particular case here, it makes a lot of sense in terms of if you're already bought in with Redux, then you can, for example, in Angular, you can use NGRX, or you can use Redux Observable, any number of things that kind of bridge the knowledge between those two particular libraries. And so, like I said, it's very, very simple, similar. Instead of dispatch, you have next, which shoves the next onto the piece. So what I wanted to talk about today is more along the lines of how we combine sequences, because there are a number of ways that we can do that, either through operators or through our creation items. So why don't we go ahead and get started with concat. So concat is a way that we can create an output of observables which sequentially emit all of the values from a given observable, then moves on to the next. So what it requires of us is that we have termination in every sequence. So what we can do is let's switch over to code and work it through. But it's always great. Do read the documentation. You can find it off of ReactiveX.io. So in the GitHub repository, we have a website in here, ReactiveX.io RxJS, and that will take you to the new documentation, which has a lot of really cool and really descriptive information, including examples. So that's where we're going to start today with concat. So let's switch over to our code view and get started. So let me clear this out because I was messing with other things. Let's do import concat, and let's say of, just to create some numbers together, and from RxJS. All right. So now let's create a couple of observable sequences. So we can say num1s is equal to of 1, 1, 2, 3, and num2s plus num$2 equal to of 4, 5, 6, and then, like I said, is we can do arbitrary numbers of these sequences together. So we have 3 sequences here. Now what we're going to do is we're going to merge, not merge, but concatenate them all together. So what we can do there is use the concat creation operator that we have above. So we can say const num, and we'll just say num, this is equal to concat, and then we'll say num1, num2, and num3. All right, cool. So we've got that, and now we can subscribe to that. Dot subscribe, and next, passing in data, console.log, and data : x. Cool. Yes, and of course, forgetting that, I've got a object here of next. All right, and because I love semicolons, and who doesn't, we'll do that. So Tia will do npx ts node here of 13 index.ts. And so it will put out our 1 through 9. Now, that's interesting, certainly that they can be concatenated together. But what about if we wanted to capture them in time as they happen? Now that's a different story, because we have, once again, many different ways about combining operators, of combining sequences. So we can either use concats like we did here, or we could use, for example, merge. So with merge, we have right here. And so with merge, we have that concurrently emits values from any given input on the given observable. So how it's different is the fact that it doesn't require one to necessarily end before the other one happens. And since, once again, this is a creation operator, in a way, we can take in a scheduler-like option. What we can also do is that we can throw in a number which says the max amount of concurrency that we want for this merge. So if we have 17 sequences and we only want 3 to go at a time, we can certainly do that. Once again, it's really up to you on how you do that, but let's go ahead and look at the code. And I realize I forgot completely over here to switch. My fault. All right, so let's go back over that again. So concurrent values at any point with our observable input over time, and then, like I said, is the scheduler object that we use for concurrency, or the number of concurrent sequences. So going back to the code here, we can now import our merge. And instead of here, I'm just going to get rid of that. And let's do instead, let's do merge. If I could spell, I'd be a genius. I really would. Merge. Why did I do that twice? All right. So merge and merge. So we also, instead of want we want interval. So we can start to have things running concurrently with one another. So we can have const num $1 is equal to interval, and make that interval of 1,000, which is every second. Then we can have num $2 is interval every, say, 1,500, and const num 3 as interval of let's make it interesting, of 500. Why not? All right, so what we can do now is we're going to merge these together, but in order to really do anything interesting, what we're going to want is we're going to want to map it to a new value so we can show you which stream it's from. So let's import map from RxJS/operators and bring in map. So then we can say .pipe and pass in map, and then say, we'll say first and okay. And so we'll have the first one, and then we'll have the second, and then we can have the third. Cool. So, and we'll take 10 of each of these because, well, this will go on forever. So we'll do take, and we'll take, comma, take 10, take 10, and take 10. Doesn't really matter necessarily how many of the takes that we do, because merging, if an earlier stream ends, it doesn't really matter. It all just kind of happens in its own way. So we can take each of these different intervals and merge them together in a concurrent fashion that we we'll set the concurrency to unlimited. But if we were going to do concat, we could have just literally said merge of 1, which will give us a concurrency of 1, which expects the first to end, then the second to end, then the third to end. So let's run this example and see what happens. So we're going to start seeing data as of, did I not save? I did not save. I am a genius. All right, so what we're going to do is we're going to start seeing data pretty quickly, and that we have them interspersed with one another. Now, had I specified merge of 1, like I said, is that we could have then limited our concurrency to absolutely 1 at a time. So it'll wait here for our values to come through on the first one before it goes to the second one, then it goes to the third one. So it goes here, it's going to wait 1.5 seconds for the second one, and then on the third one it's going to wait half a second to go through each of them. With me so far? Perfect. So, like I said, this is the difference here between concat and merge, in the fact that we can allow any number of them to be in flight at any given time. So, what else could we do here that's fairly interesting now that we have concat and we have merge? We'll talk about the mapping and merging at a later point, because that's more of an operator that we'll just talk about then, with merge all, concat all, combine all, etc., etc. But what we can do is we can start to look back at zip and combine latest and with latest from. We may not get to with latest from. We can certainly wait till another episode for that. So let's go and comment out this code and start again. So let's go back to our browser here and take a look at what exactly zip is. So zip is a functional programming concept that's fairly common, which is to take like sequences and combine them together so that you've got both left and right, or in this case infinite streams together, so that you've got a way of combining these sequences. But those sequences, once again, are matched in a certain way. So what we can do is create, just to show an example, is we can take of different types if we wanted to and combine them together. So let's go back into our code scene and create our nums again, and instead of using always with numbers, if I can do 1, 2, 3, and I can do const num $2, and it's not really a num at this point because I'll do foo, bar, and baz, and so on and so forth. So what we can do then is import zip here and say, we'll keep this one out here because I don't like having to retype this. So we can now say const num is equal to, and let's zip together. And in fact, I just want to combine together num1 and num2. So let's do that, and num2. So by default, there's no selector operator, although you could certainly do that after the fact with map. Otherwise, we'll just give you a raw array. So if we look at running this through, we'll in fact get an array back of 1 foo, 2 bar, and 3 baz. So once again, each index mapped up to one another. Now, what would be more interesting, like I said, is that what if we could combine our sequences during a specific period of time in such a way that that we combine the latest from each of our streams as they go through. So now that we've got this down below here with our interval and pipe, why don't we just go and show you what that might look like if we use combine latest. So let's import that, combine latest. And that is that it will take the latest from each and every stream and emit a new data piece as it comes through. So that's kind of cool that we can do merge, we can combine these things in any number of ways, and getting rid of one dummy. All right, and what happens between these particular things here. So when the data comes through, we're going to get the first, second, and third combined. And instead of being, let's do 5 instead, because it might make a little more sense of reading the output from there. So doing combine latest, what's going to happen? Well, what you see is that we have first, second, and third combined with 1, first, second, and third combined with 2 of 0, 0, 2, 0, 0, 1. So every time that this one is fired, this one has fired more than this one and this one have. So it starts emitting data. In fact, a piece of data is actually lost because of the fact that 0 happened to pass before any of the others were actually ready to emit a value, because it's not just going to pick random ones out of there unless they started with some data. This one in particular is more along the lines of that we've got data as it comes through, and whenever we get anything new from any of those 3 streams, we shove it into the stream along with the latest from each and every stream. So once again, very, very cool. And if we go back and look at the documentation on combine latest, we'll see that it once again has really comprehensive documentation on how we combine those 2 particular values together. So we have examples here. So once again, if you really want to have more advanced examples, many of these are sometimes out of date in terms of having dot notation on them, but hopefully we'll get that cleaned up soon enough. So that's really what I wanted to talk about, which was merge and concat and zip and combine latest on terms of how we start to combine together sequences. With that, we've hit the 30-minute mark once again. So I want to thank everyone for showing up today and hanging out, and I really appreciate it. Any feedback is welcome, and do follow me on Twitch at Bluer Than Blue Falcon, on Twitter at Matt Podwysocki, and find me on YouTube as well. So thank you all, and so long, and I will see you next time.